All right, here we're going to determine the inverse Laplace transform of the given function. One way to approach this, which is the way I'm going to do it, is I can write g of s is e to the negative 3s times f of s, where f of s is this function 6 over all that stuff there, s squared minus 4s minus 5. Now, why would I do that? Well, we have a formula that says the Laplace transform of u a t f t minus a is equal to e to the negative as fs. So that's why we're going to do that. And so therefore, if this would tell us that g of t is equal to u3t f of t minus 3. So the challenge will be for us to find now the challenge will be for us to find f of t, little f of t. There's all these little pieces on this formula that get me nervous. This negative as, and this is positive a, things like that. It just anyway. But we're gonna find f of t. All right. So f of s is 6 over s squared minus 4s minus 5, but we can also just pay attention to saying, okay, this is a rational function, and with rational functions we need to factor the denominator if we can, which we can in this situation, and but we factor completely. This does factor, and then if necessary use a partial fraction expansion, which is what I'm going to use here. So we're going to use partial fractions. So 6 over s plus 1 s minus 5 is equal to a over s plus 1 plus b over s minus 5. And then if I multiply through, I get a times s minus 5 plus b s plus 1. And then if I let s equal negative 1, which is a convenient number because s being negative 1 makes the b term disappear. That's going to give 6 equals a negative 1 minus 5 plus 0. So 6 equals negative 6a, and so apparently a is equal to negative 1. All right, so conveniently it's an integer, not a fraction. All right, then if I let s equal 5, why am I going to do that? Because 5 minus 5 is 0. That'll give 6 equals a times 0 plus b 5 plus 1. So 6 equals 6b. So b is equal to 1. So, it's a problem that was chosen particularly so that I will have integer solutions. All right. So f of s is equal to all this stuff here, a over s plus 1 plus b over s minus 5, but now we know what a and b are. So it's negative 1 over s plus 1 plus b, which is 1 over s minus 5, and we have a formula that's sort of a good one for sure. The Laplace transform e to the at is equal to 1 over s minus a. And so f of t is going to be equal to negative e to the negative t plus 1 e to the 5t. Okay, so the thing is that these little things, this plus and minus, I find it a little bit of a challenge. Okay, but Laplace e to the negative at is 1 over s plus a. So you know, it's okay. There's a little something there. All right, but the thing is that that was just focusing on that one piece. That, what did we do? We found f of t. All right, now I go back, and if I want, I can, does this make it any clearer out of all this stuff? Maybe not, but could be, could improve this. So I'm going to snail track over here of what this part, that g of t. So g of t is equal to u3t of f of t minus 3. So I copy and paste the f of t, but I replace t by t minus 3. And don't you think, one of the issues is I sort of ran out of space. And it makes everything look worse and harder to think. Maybe I should have written down above, just rewritten that line. Okay, so, all right. So much going on here. All right, so here's the thing. If you see an exponential, when we're looking at inverse Laplace transform with S, if you see exponential, then what you can do is you can take that exponential and multiply it by a function f of s. You define f of s. And then here's f of s right here. We went through lots of stuff with partial fractions, but you find the inverse of f of s, and that's f of t. And then what happens, you have g of s is e to the negative 3 as f of s. There is a formula that says that the inverse of that is u3t f of t minus 3. By the way, u3t is the unit step function. So see, now when I get f, I can just put it right in there. Okay, and nothing is just do this. It's all work for sure. But there we go. Okay, goodbye.